Okay, this is problem number 6 on the final review for trigonometry, the final. And it's essentially, it's an identity problem. You can call it what you want, but it's an identity problem. You find these, they actually have them in the identity under fundamental identities. So we should be able to solve these with just the fundamental identities. And it's your first identity problem, so let's talk identities. What it's asking us to do is to write cosine x. In other words, write an equation that calculates cosine of x, but only uses sine of x in the equation. Okay, so we want to write cosine of x, but we want to write an equation that only uses sine of x. Well, so maybe we've got some application where we're going to be given the sine, but we want to find the cosine, and we're always going to be in quadrant 2 for some reason. So what does that mean? Well, if we're in quadrant 2, it simply means that the sine is going to be positive, the cosine is going to be negative. We just need to remember that when we're done, and we'll make that adjustment at the last minute. Okay? So if you looked at your identities at all, one of the fundamental identities is the what we call the Pythagorean identities. And the Pythagorean identity just simply says that if we square the sine, we square the cosine, add them together, we're going to get 1. And so we're going to start with that. Sine squared plus cosine squared is equal to 1, because we can solve this for cosine, and we'll end up having something in the end that looks like cosine equals and a bunch of blah, 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 but the only thing in the blah, blah, blah is going to be a sine. Okay? So real quickly, we're just going to solve that out. We're going to subtract sine squared x from both sides, and we're going to take the square root of both sides. And at this point, you've done 90% of the work. You're all but done. The only thing we have to consider is we're calculating cosine of x in quadrant 2. So we know that we're always going to get a negative answer for the cosine. But when we look at this, we're always going to get a positive answer for 1 minus sine squared of x. And that's just because even in quadrant 2, sine squared of x is always going to be positive. When you square it, it's going to be a positive number that's maybe even a little smaller. And 1 minus that number, since it's always going to be less than 1, is going to be a positive number. So this is always going to come out positive when you are in quadrant 2. You're just limited. Every angle here in quadrant 2 is going to get you a positive number. But cosine is negative. So how do we adjust for that? We just say, well, let's just take the negative only. And so cosine x is always going to be equal to the negative of the square root of 1 minus sine squared x. And that's all there is to it. That's actually a pretty simple problem. It looks complicated, but if you just say, well, let's just start with an identity that uses only those two things. And the key here is, whichever two things here are given, you need to think of an identity that only involves those two things, and then solve for the one, and then adjust for the quadrant if it asks for it. And that's really all you have to do.